Here I have a nice looking part from some of our friends from ETS. It actually has quite a bit of detail in it, and I'm going to go ahead and have to machine it using Camworks. So let's go ahead and get started. We'll take a look at the plate, and Camworks works right inside of SolidWorks. So you'll notice that the only two differences is that we have two extra little tabs in the feature manager, and we also have a ribbon on the toolbar. Now Camworks works directly inside of SolidWorks, and it just launches as an add-in, similar to some of the other programs that you may use. Camworks has been a long-time partner with SolidWorks since 1996, and when you purchase Camworks, you also get Solid Professor. So if I search on Solid Professor for Camworks, you'll see some of the courses for how to use the Camworks mill, the turning, and the EDM portions, and they have more to come. For the most part, Solid Professor is just a video library that's going to help you get started. Let's go ahead and get back to the part. Camworks has two different tabs. One is the feature tree, and the other is the operation tree. On the feature tree, we can go ahead and set what our stock limits are. So if I edit the definition on there, you'll notice it uses the envelope or the bounding box of the actual part to go ahead and define its parameters. We can also use a sketch, or we can import an STL file if we're actually machining from casting. Now this plate is already set the correct height, so I do want to go ahead and change some of the external components on the X, and I'm going to go ahead and hit the X so that way it does it in both directions. So you can see I've got a little bit of space on both sides, and then I'm also going to do it in the Z. I've got to take a look at my X and Z is kind of a little bit flipped from here. So I'll go ahead and add a little bit of extra material. Last thing I need to do is go ahead and set my stock. So this is 6061 T6, and we'll hit OK. The interface is fairly simple. The next thing I need to do is tell it what type of machine I'm going to use. So I edit the definition on the machine. If I go to the machine tab, you can kind of see I can pick mill turn, or wire EDM machines. In this case, I've already picked a mill inch, which is normally a 3-axis. We have a tool crib that we can actually tell what different types of tooling we're going to use. And I also need to tell it what type of post we're going to use. In this case, it's just a 3-axis, and it's a Funuk type post. So go ahead and say OK out of there. And before I actually start creating some of my code, I'm going to take a look at some of the Camworks options. On the Mill Feature Types tab, I'm going to come down here. I'm going to tell it not to do any facing. And the reason is because I've got my plate steel, and I don't really care for it to do my part parameter. I also don't have any tapered or filleted tops on here. I do have some chamfers, and we'll take care of those later. So I'll go ahead and say OK. And now I'll let Camworks go ahead and do its work. So I'll extract the machinable features. They usually call this Automatic Feature Recognition, or AFR for short. And so Camworks has already created some mill part setups. These are where we're going to have to take the part out of the chuck and reorient it. So you notice that this is actually on the side view, where it actually has to machine these holes. I have a mill part set up on the other side. I have one on the very top, which is going to be my main part setup. And then I also have some stuff on the bottom that I may need to do. Now what we do is these features are actually linking to the geometry that's out there. And then under some of these, we actually create the operations. Under the operations, it may actually do multiple passes, or a roughing and a finishing pass. Or in this case with the countersunk, I'll go ahead and generate the operation plan. And you'll notice it does a center drill, a drill, and a countersink. So all of these operations actually pertain to these individual features. They're linked automatically. Next, all I got to do is tell it to create the toolpath. So all I got to do is select it, right click, and say generate toolpath. And there you can kind of see the toolpath as it's going in. If I want, I can also simulate the toolpath. And you can kind of see we got a nice little simulator that goes in there and does that for us. The countersinks look a little bit big, but that's because I haven't faced around the outside of this part yet. Also, when we're on the Operations tab, we need to tell it where our part 0 is. Now, I haven't actually drilled this hole yet, so I don't exactly know where it's at. But after I'm done contouring the outside profile of this, I will know where this top left-hand corner is. So all I got to do is simply right-click, edit the definition of that part setup, and I'll just select on a vertex, and now I'll put my X and Y in that location. So now when I generate my code, everything's going to come out correct. So that finishes off that face. Let's go ahead and do the countersinks on the other side. So those are done. Now I've got the mill part set up on the top, which is actually going to do quite a bit of work. So let's go ahead and see what it does. We'll just hold down Shift, select all those features, and right-click Generate the Operation Plan. It's quite a bit more stuff to go through. Select on the mill part setup 15 here, and I'll tell it to generate the toolpath. As I hover my mouse down through here, you'll start seeing some of the toolpath. And it's very simple. When I get down here, in case this rough mill, I may actually want to take care of that with the outer perimeter. So I'm going to go ahead and highlight both of those, and just simply right-click and hit Delete. When you delete them, we actually put them inside of a recycling bin, so that way if you actually forgot or messed something up, you can always get them back. All you have to do is right-click and tell it to restore them. Okay, in this case, I do want to go back, and I actually want to put in my own little part feature, and I'm going to put in a part perimeter. I'm going to go ahead and do a course strategy, and I'll just hit OK. So here's my perimeter, the outside part of the pocket, and all I have to do is generate the operation plan, and it gives me a rough and then a contour. So I can do a rough and then a finishing pass. And again, all I have to do is create the generate the toolpath, and I've got some good looking toolpath out there. Now if I wanted the rough mill and the contour mill to actually be the first operation in there, I could just simply drag and drop it to the top. But I do have some automated ways in which I can sort the toolpath either by operation or by tool. So that way I could tell it to do all the operations with that tool at the same time. In this case, I am just going to go ahead and drag up the rough mill and my contour mill, and we'll do those first. Meanwhile, while I'm tidying some of this stuff up, you can kind of see I can also take, I want to do the mill part setup 15 first, so I'm going to take the entire mill part 14 and 13 and do them underneath the 15. So we're doing all the outside components first, and then the mill part setup on the side, and then the mill part setup on the other side. I've only got one more bit of features that I need to do, and that's on the back of the part. I've got some countersinks that I need to make sure that it does. Now you'll notice on this mill part setup 16, it actually found quite a few different features. It found that countersink, the little countersink holes down here, but then it also found a lot of these other holes that go all the way through the part. Well, those guys are already taken care of from the front of the part. So in this case, I really only need to generate the operations for these two features. So here's my mill part 16. Again, select on the operations and just generate the toolpath. Next, we'll go ahead and flip this guy over, and let's simulate this and see how well Camworks did. So just right-click and simulate the toolpath. I'm going to go ahead and speed it up so it runs quite fast, but we do have a little thing where we can slow it down, and then we can speed it up. And you can kind of see it's also highlighting the different features as it's doing it. You see I'm wasting quite a bit of space or time as this thing's doing a parallel lace in probably the wrong direction. Also, I could probably get a larger tool in there, so I may need to change and edit that soon. So we'll go ahead and fast forward it to the end. And I also noticed that I'm missing the little cut on the side of this. And it's not that Camworks didn't find it, which it did. The only thing is I don't want to do a whole mill part setup to do that. So let me go ahead and close out of there. And I'm just going to add in a part feature. So I'm going to do a 2.5 axis feature. Just going to be an open profile. And I'm just going to select on this little edge right there. I need to tell it where to go from the top. So I'm going to say up to face, and I'll just select on the top face. So now it knows exactly what the depth of that thing is supposed to be. So we'll go ahead and finish out of the feature. You'll now see an open profile. All you have to do is generate the operation plan. So there's my contour mill. I'll go ahead and edit the definition on that guy. And I'm going to go ahead and change the lead in to parallel and the lead out to parallel as well. And then I can give it a very big, large lead in amount, say for instance 2.5 inches, and we'll go ahead and lead it out about 6.5 inches. I can hit the little preview, and now you can kind of see what my toolpath is actually going to look like. I can double click on the operation plan. That gets me back into the feature dialog. I'm going to go to the tool, and I'm going to take a look at the little tool. You'll see it's highlighting exactly where my cursor is, and that's just going to kind of pretty much whack off those little edges there. So we need to change our tool. Now my tool crib, I don't exactly have the right part for this, so I'm going to go ahead and add it from the library. So in this case, I'm going to go get a keyway. I'm going to go pick a 1-inch slaughter from here. Go ahead and scroll down to the bottom and actually select it. Replace the holder. So now you can kind of see I have a little keyway holder, but it doesn't look like the right size. So I need to change some of the parameters, and I can do that on the fly. I'll go ahead and change the diameter to a 2-inch. Change the flute length to 1/4. So now you can kind of see what I'm starting to get. I could probably do this if my shank diameter was a little bit smaller as well. I can rotate around, and I want to make sure that I can get that through there. That looks pretty good. So I hit the little preview on that. You'll notice that the toolpath goes ahead and it offsets from the edge of that. So we're going to come down here. We're going to go all the way across here, finish up right here, and go ahead and pull out. Go ahead and hit OK, and my toolpath is complete. Looks like we got the part pretty much done. So now all I want to do is verify it and make sure that it's going to run correctly. So again, I'm going to right click on the very top and we'll simulate the toolpath here. I'm going to go and run it all the way through here in a very fast mode. Notice you'll have my little cuts down here, and we can also compare it and show the difference between the actual cut part and the actual part itself. So I get a little graph that indicates that anything that's close to a certain tolerance, in this case 0 inches, is actually out here in green. So majority of my stuff is actually green. And you can kind of see I've got a little bit of blue here where I may need to actually change my tool out, and I've got a little bit of red which may be an overcut. So I may need to actually find a smaller diameter tool, or I may need to go in there with a small end mill and actually route that out. But it may be okay. We can always check it later. I did want to fix one more little bit of toolpath, and that was on this rough mill. I saw that it was taking quite a bit of time and the parallel lace was going in the wrong direction. So all I have to do is edit the definition. You notice it's using a 1/4 inch end mill. So I'm going to go to the tool crib. We'll go down and find a 1/2 inch flute. Select it. We'll replace the holder. Next I'll go to the roughing tab, and I'm going to change the cut angle to 90 degrees, and I'm going to take a look at the preview before I get out of the dialog box. So that looks quite a bit better, but I can actually do it with just 2 passes. So on the depth parameter, change this to a 1/4 inch and the max cut to a 1/4 inch. Hit the preview, and now I'm only stepping down two times. Now that that's done, I do want to go ahead and check the finishing pass on that as well. So we'll edit the definition on him. And notice that he's just finishing on the side face of this. Well, I also want it to finish on the bottom because that may be something that needs a good surface finish. So on the contour tab, I'm going to click on bottom finish and I'll hit OK, and now I get a nice little bottom finish on there. I'm also using the smaller tool, so that comes up in the corner correctly, and it should give me a nice little finish on that. One more finish or feature I wanted to take care of is the rough mill on here. I'm going to edit this definition, and I'm going to go ahead and change my tool to something a little bit larger. So I'm going to select on this guy and actually change him to a 2 inch. So I should be able to hog this out pretty quick. But I want to change the way that I want to come into the actual part. So on the Features Options tab, I'm going to change my plunge to a spiral entry. I'll take a look at the preview on that. Doesn't look any different, so let's change some of our settings. We'll do a 1/2 inch radius with a 1/2 inch pitch. And now we've got a nice little spiral coming in. That's exactly what I want, so I hit OK. And now the toolpath looks satisfactory to me. Next, before I step the code out, I'm going to go ahead and go into the setup sheets, and I'm going to go ahead and generate a setup sheet. And we have a couple different templates that you can use depending on what you want to actually see. So in this case, I'll use template 4. Wait for it to generate. Then it's going to open it up in Windows Explorer, and you'll notice I get a nice looking tool list of all the different tools, the feeds, the speeds, the RPM setup, and everything that I need to complete my job. So now I'm ready to post my process. I'll go ahead and save this as a text file, but I can also change it to just an NC. So I'll hit the save button. We'll go ahead and hit the play button. That'll create the NC code. You'll notice that Camworks is very fast at this. I'll go ahead and say OK. And let's go ahead and take a look inside of Internet or Windows Explorer and see what all we've got. I'll go ahead and close out of these files just so you can see. You can see them without all the temp files. So there I've got my SolidWorks part, I've got my drawing, and then I've got this NC file. I've got the XML file, which is my setup sheet, and it also has a style sheet that goes along with it. Now that's kind of a little bit of extra stuff, and I don't care to actually put that in there. But something I do want to do is on this drawing actually contains that part. But Enterprise doesn't know about that until I actually check it in. But before I check it in, I also want to link this NC file, the text file, to the actual part to make sure that whenever I check something in or check something out, I can tell that it's linked. So all I have to do is right click on it, copy, select on the actual part, and I'm going to do paste as reference. So you'll notice that underneath the part, now there's an existing NC file, and Vault or Enterprise is going to know that that is a linked child-parent relationship. So I'll say OK, and then now if I go ahead and check this guy in, and when I go to check the drawing in, you'll notice it's referencing the part, and that part is actually referencing the NC file. Now there are some references to the SolidWorks part file that are coming from an assembly file, but I wasn't given those, so I'm not going to check those guys in. So I'll go ahead and check the files in. Now you can see the full contains underneath here. Also, if I just select on the NC file, if I use the where used, then you can see the NC file references the part references the drawing. So I know what needs to be affected if an update needs to take place. You'll notice that the state is set to work in progress. Now I've gone ahead and set up in Enterprise a work in progress state. So now I need to actually send it to approval, and then after approval I can send it to a release state. That'll lock it down and make sure that it can't be accessible unless we get an engineering change order where I can change it back to a work in progress, approve it, and then re-release it. So very simply, all I have to do is I'll just select on the drawing itself, right click on it, change state, and I'll go into the waiting approval state. Now you'll notice that the NC file is in the wrong state. So as far as the engineering change order process, as far as the drawings and the parts, this is going to work just fine, at least for the engineering. So now it's in waiting approval, and somebody else, probably a manager or engineering manager, should come in, select on those files, and actually change them to where they pass approval and they go into a release state. So that's good for the engineering side. This is also going to create a PDF file. So I'll go ahead and let it do its work. But let's go back to the manufacturing side. So I have the NC file out here. Let's go back to our workflow, and I actually have a simple workflow, not the CAD files, but a simple workflow where it goes from work in progress just strictly to approved. And I may need to actually log in as somebody else, like a manufacturing manager, to actually push that through. So I can right click on him, change him to approved, create his little PDF if you like. And now you can see he's in a release state. So we could have different file types actually go through different workflows depending on what different departments they're in. And the thing to check and make sure that we have everything set up right, we might need to look at the data card. And we'll have to check and make sure that revision A is set for both the drawing, the part, and the NC file. If it's not set right for the NC file, then we know that somebody's got to do some work. So hopefully you've seen some great workflows on taking a SolidWorks part file, putting it into Camworks and actually generating the code. Everything is stored right within the SolidWorks part file, so there's no external files other than the NC code or any type of reports that you may want to export. Then we've checked it in using Enterprise PDM, and we're able to send the drawing and the part file through two different separate workflows, separate than the NC file going through a manufacturing process or workflow. Hope this helps and enjoy. Thanks.